Now that you've had the chance to try out a percent yield problem on your own, we'll go through the answer to this question together. On your test, you can expect to see one question that requires you to do a BCA table and then calculate the percent yield. For this question, it says that you are reacting hydrogen gas and oxygen gas to produce water. So as always, when doing a BCA table, we're first going to start by writing a balanced equation. Hydrogen plus oxygen to produce water. And we can see that this is not balanced right now. And so since we have 2 oxygens on the left-hand side, we'll need to put a 2 out in front of the water to make there be 2 oxygens on the right-hand side. That now gives us 4 H's on the right-hand side, and so we are required to put a 2 out in front of the H2 to give us 4 hydrogens. Now that this reaction is balanced, we can create our BCA table. And as always, we start by filling in our BCA table with the numbers given to us in the problem. It says we have 15.4 moles of hydrogen gas and excess oxygen gas to begin with. We know that our products always start as 0. Then we're going to solve our BCA table as always, and we're going to subtract our reactants, add our products, and we will subtract all of the substance that we know we have, the whole 15.4 moles, and anything with the same coefficient of 2 will also be 15.4 moles. To figure out the number that goes in the change row under oxygen, we are going to cross multiply by putting the coefficient of 2 over 15.4 and setting that equal to the coefficient 1 over x. When we do that, x is equal to 7.70, which is what we'll fill in for oxygen. Then we can just complete the table doing our after row by doing the math. So 15.4 minus 15.4 is 0, excess minus anything is excess, and 0 plus 15.4 is 15.4. We're not done yet though, because the problem asks us to calculate the percent yield of water. So that means we need to take the amount of water that we've produced, the 15.4 moles, and we'll need to change it into grams because it tells us in the problem that we have 265 grams of water that was actually produced. That number, 265, is my actual yield. So to find the theoretical yield, like I said, we're going to take our 15.4 moles of water. We're going to change it into grams using our mole roadmap. So 1 mole goes on the bottom and the molar mass of water goes on top. So we'll add up 2 hydrogens plus 1 oxygen off our periodic table to give us 18 grams. When we do 15.4 times 18 divided by 1, we get 277 grams, which again is our theoretical yield. Percent yield, if you remember, is the actual yield, 265, divided by the theoretical yield, 277, times 100 to give us a percentage. When you do that math, you get 95.7%.